Bismillahirrahmanirrahim. Assalamu alaikum girls. This is discrete mathematics for BSIT student. I am Ms. Sumaira. Today's topic is biconditional and truth table. We have discussed about and, or, not, and if-then compound propositions. Now we will discuss biconditionals. What is the biconditional statement? If we remove the if-then part of a true conditional statement, combine the hypothesis and conclusion, and tuck in a phrase if and only if, we can create biconditional statements. How to write a biconditional statement? The general form is hypothesis if and only if conclusion, or you can write it as conclusion if and only if hypothesis. Notice we can create two biconditional statements. If conditional statements are one-way streets, biconditional statements are the two-way streets of logic. Biconditionals. Let P and Q be propositions. The biconditional statement is the proposition P if and only if Q. The biconditional statement P if and only if Q is true when P and Q have the same truth values and is false otherwise. Biconditional statements are also called by implications. Now look at the truth table for biconditionals. In this, the first column is for the P proposition, the second column is for Q proposition, and there are four possible combinations for the two propositions. Now the last column is for P if and only if Q. If you look at the answer of your P if and only if Q, then it is true only if both propositions have same values. Like P is true, Q is true, then the answer is true. When P is false, Q is false, then the answer is true. Else it is false. More explaining about truth table for biconditional. Now here we have proved one thing, that biconditional is actually and of P implies Q and Q implies P. Again, looking at the truth table, the first column is for P proposition, the second column is for Q propositions, and all four possible combinations are given. Next is P implies Q. Keeping in mind P as the first propositions, then it will be only false if the first is true and the second is false. Then we have the answer false, else it is true. Similarly, the second column is for Q implies P. Now here, keeping in mind that Q is the first proposition, so we will check from the Q side. So it will be only false when Q is true and P is false. So just check those possibility where Q is true. In the first, Q is true, but P is also true, so the answer is true. Next, Q is true, but P is false. So here the answer will be false. So both are P implies Q and Q implies P. In the last column, we are taking their and we know that and is only true when both are true, else it is false. The first P implies Q and Q implies P, both are true, so the answer is true. P implies Q is false, so the answer is false. P implies Q is true, but Q implies P is false, so the answer will be false. In the last, P implies Q is true and Q implies P is also true, so the answer is also true. Now if you observe, by taking the AND of both implies conditions, we get the same truth table, that is of biconditional. So biconditional, here we have proved, is also known as AND of P implies Q and Q implies P. Consider an example. Let P be the statement, you can take the flight, and let Q be the statement, you buy a ticket. Then P if and only if Q is the statement, you can take the flight if and only if you buy a ticket. Now see some more examples. The polygon has only 4 sides if and only if the polygon is a quadrilateral. Mean if a polygon is going to have 4 sides, then it is known as a quadrilateral, and vice versa. The quadrilateral is a square if and only if the quadrilateral has 4 congruent sides and angles. Mean a quadrilateral is going to be said a square if and only if it is having 4 congruent sides and angles, and vice versa. Now see some important definitions. Tautology, the statement which is true for all possible values of the variables in it, is called tautology. Mean if your answer column is containing all true values, then it is known as tautology. Contingency, the statement which is true or false depending upon the truth values of the variables involved in it, is called a contingency. Mean if your answer column consists of true and false answer values, then that is known as contingency. Absurdity or contradiction, the statement which is false for all possible values of the variables involved in it, is called an absurdity or contradiction. Mean if your answer column is having all false values, then it is known as absurdity or contradiction. Let's see some examples. Construct the truth table of the compound proposition P or not of Q employs P and Q. Now first see that what are the things given to us in the question. Left hand side is P or not of Q, and right hand side is P and Q. And two proposition P and Q are involved. So in the solution truth table, we are going to write down first the given number of proposition. As two propositions are involved, so we are writing two proposition P and Q and make their combination true, 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 false, false, true, and false, false. Next, see that on the left hand side, we need P or not of Q. So first we will make this left hand side. In this first we are going to make not of Q. So the third column is for not of Q. Not of Q mean opposite of Q. If Q is true, then not of Q is false. If Q is false, not of Q is true. Then the third column is for the parenthesis P or not of Q. Or mean that if either one of P or not of Q is true, then the answer is true. So for this we are going to see two columns, P or not of Q. So in P column, first one is true and not of Q is false. But being P is true, the answer is true. Then true, true, answer is true. False, false. As both are false, so the answer is false. False, true. The answer is true. Now see the right hand side of your given compound proposition, that is P and Q. So the next column is for P and Q. P and Q mean if both P and Q are true, then the answer is true, else it is false. So only the first option where both are true is true, the rest are false. Now see your given question, P or not of Q employs P and Q. As both columns are ready, now we are going to use the employs sign, if then P. Now here P or not of Q is true, true, false, true, and P and Q is true and then all are false. As employs only false if the first one is true and the second is false. So we are going to check it out all the option. First is true, second is true, so the answer is true. First is true, the second is false, so the answer is false. Both are false, answer is true. First is true, second is false, answer is false. As the answer column consists on true and false both values, so the given statement is contingency. See another example. The statement is P and not of Q if and only if not of P employs Q. We need to construct the truth table for the given statement. As in the given statement, two propositions are involved, so we are going to make the truth table for the two proposition P and Q. So we write it down P and Q and all the possible combinations of P and Q. Next, see that on the left hand side it is and of P and not of Q. We have already P column. Now we are going to make not of Q. As not of Q is opposite to Q, so where it is true, not of Q will be false. Where Q is false, not of Q will be true, and all the remaining statement. Now see that on the left hand side that is P and not of Q. And mean that if both P and not of Q are true, then the answer will be true, otherwise it is false. So see first and third column. True, false, answer is false. True, true, answer is true. False, false, answer is false. False, true, answer is false. Now see the right hand side of your given question. It is not of P employs Q. So we are going to make P employs Q first and then we will apply not on it. Employs can mean that when the first is true and the second is false, then the answer is false, else it is true. So P is true, Q is true, answer is true. P is true, Q is false. So here the answer is false. P is false, Q is true, answer is true. P is false, Q is false, answer is true. Now next we need not of P employs Q. So we are going to apply not on P employs Q, mean we are inverting it. Where it is true, we are going to write false. Where it is false, we are going to write true. So we just write it down. Next is the answer that take the equivalence or if and only if of both P and not of Q and not of P employs Q. Mean fourth and sixth column. When you take if and only if of these two, we know that if and only if condition mean if both have same truth values, then the answer is true. Mean if both are false or if both are true, then the answer is true. Otherwise it is false. So first is false, second is false. Both are same, so the answer is true. First is true, second is true. As both are same, so the answer is true. First is false, second is false, as both are same, so the answer is true. Last is false and again the second last is false, answer is true as both are same. As you see that all the answers are true, so given statement is tautology.